Picking up on extra practice number 6, our formula for the surface area of a cone. Capital S equals pi r squared plus pi r times little s. Now, little s is what we have to solve for, and I tried working it out a moment ago, and too many people got lost, so we're going to do this again. So just because it's difficult doesn't mean we're stopping. Just because it's difficult doesn't mean we quit. So if I've got to get this guy all alone, I have to start undoing things just like I do when I have a less complicated formula. You know, like, how do I get these pieces away? Go ahead, Jaquan. It's the pi formula, you have to. No, use pi symbol just the way it's written. So my first step is, why am I doing this? Well, I've got to get this group away from my little s. I've got to undo to get little s alone. First thing I'm going to do is I'm going to move this pi r squared to the left-hand side. And so I can do that by the subtraction property of equality. Oops, it should really be on this line because I'm going to come down and I'm going to actually have capital S minus pi r squared equals pi r little s. Go ahead, AJ. Get over it. We're not going to use that. It's an estimate. You can draw it. What questions now? Still honing in on little s. Still, I'm waiting.
Do you always subtract it when it's a square?
I subtracted it. I subtracted it because it was a positive number. Pi rs is positive. How do I undo a positive number? I subtract. Like if it just said 6 plus pi rs, you would have said subtract 6. Does that make sense?
Yeah.
Okay. Jaquan.
But I subtract the pi rs and pi r squared.
So I can't put these together because they're not like terms. And how do I subtract? There's this rule that I just justified that says I can subtract anything I want. I can subtract chicken from both sides of an equation as long as I subtract chicken on the left and subtract chicken on the right. I mean, it sounds silly, but that's how, because as long as I do it to both sides. And those pi's wind up sitting there. Lena.
Okay, so
Please stop talking unless you're asking a question.
is that a little s at the beginning?
This is a capital S, this is a little.
Okay.
Let me make this bigger.
Right.
Capital S stands for surface area. Little s is standing for what they call the slant height. Capital S stands for surface area. Little s stands for slant height.
So is it possible you could have subtracted it with the s, the other one, or do you just have to do that?
I have to get slant height alone. So there's no other way of going.
The s and we don't just subtract it first.
I want to leave it alone.
Okay.
So moving it wouldn't have gotten me anywhere. Go ahead, Kennedy.
Why your s all fancy? Did that mean something?
Regardless of how my S is written, right now you see the difference between capital and little, meaning slant height versus surface area. Better? Write down what they mean. No. So at this point now, I'm going to get back to where I was before. And I'm going to talk about how this pi rs is all multiplication. And so in order to get rid of pi r and leave s alone, I have to divide everything by pi times r. Just like in the last problem, that means on the left-hand side, I'm going to come over and I'm going to divide every piece times pi times r. So I'm going through and writing down every piece is divided by pi times r because, again, little s in the slant height needs to get left alone. So at this point, I can start saying, well, that divides out, that divides out. And actually, speaking of division, it's the division property that let me do this. And I go over on this side, and this capital S, this capital S over pi times r, there's nothing I can do with it other than say the surface area divided by pi times the radius is going to be sitting right there. Now, I'm going to take one step further with this. I'm going to write this numerator as pi r times r because r squared is the same as r times r. This is a step I didn't write out when we did this problem a moment ago. So we're still at little s and slant height on this side. We're still at capital S over here. They haven't moved. I won't need to move them anymore. I wanted little s alone, and now it is. Lena.
I'm confused. Pi times r.
Okay, I'm not done yet.
Oh wait, never mind. I know.
You see the r squared?
Yeah.
Yep. So I broke down r squared into r times r because when I'm sitting right here then, see what I can divide out over here? Pi over pi is going to go away. R over r is going to go away. So I'm actually going to finish this problem by saying capital S over pi times r minus r equals little s. Now let me go drop this back in here again. Slant height, surface area. And then I go back to what my original problem asked, and it said put this into the formula solving for S, and then find the slant height. So now it wants us to actually put values in. When the surface area is 224 square feet, so now they're saying let your surface area, your capital S, be 220, and your radius be 7. And they even go so far as to say approximate your answer to the nearest foot. So now I'm going to use substitution. And I'm back on number 6. There was lots of things going on right here. We're not doing middle school geometry anymore. We expect there to be lots of layers. Lena.
So for this one, are we going to use the pi number?
We'll use the pi key in our calculator. So then for substitution, this is going to go and look like up top 220 over pi times 7. And I'm just putting a parentheses around this 7 because it's pi r. I'm putting parentheses around this 7 just to show that it's going to be pi times 7. Then I have to subtract the radius again. Whoopsie. I shouldn't be putting an r there. I should be putting a 7 there. So I'm going to subtract the radius. Somebody's got a calculation in there. That's cool. I need it. I'm going to... Give me a second, and I'll ask you again for it. So that looks funny, but my whiteout's drying. 220 over pi times 7 minus 7 equals my little s. Jaquan, when you did 220 divided by pi times 7, what'd you get? Go into your calculators and do 220 divided by pi times 7. You'll find the pi key above the caret. So 220 divided by, and then above the caret is pi times 7. Well, that's not right. Let me put parentheses around the bottom. 220 divided by, heads up, pi times 7 needs to be in parentheses on the bottom. Oh, it's about 10. It's about 10, 10.004. I'm going to actually put that in. Nah, I don't think I need to.
Don't the pi gotta be on the outside of the parentheses?
Well, the denominator had this in it, so what I really need to make sure I do is that I put this denominator in my calculator with parentheses around it. So it actually winds up being about 10.004. I'm going to drop that in there right now. It's not exactly 10. This minus 7 is going to get me my slant height. And that's going to be about 3.004 is my slant height. But it did tell me to round someplace, so let me see. It said approximate to the nearest tenth. So to the nearest tenth, you know what? Yep, my slant height is going to be, I'm going to drop it at 3 or 3.0. A couple more literal equation solving examples, and it's coming right off of your 2.4 homework. So this is going to be off of 2.4 practice A. And I'm going to move to, it's going to be problem number 5 and 6. And they tell us in each case which variable to solve for. This is a volume formula. Capital V equals pi times r squared times h. Pi r squared h. And in the directions, they want us to solve for h. So not quite as many steps as what we had on the other one, but the same idea. We've got pi, we've got multiple variables. A literal equation is usually a formula that in terms of other variables. Multiplication is implied right here, pi times r squared times h. And undoing multiplication, this actually isn't too terrible. What do I do to undo the multiplication? Divide by what? Pi r squared. You can be more specific than that. Let me tell you, my expectation is that you are. Divide my pi out. R squared, bye-bye. Both r's are going to go bye-bye. So then I'm in this case right here. H is equal to, this is volume, radius, height. Volume, radius, and height. I think this is the surface area of a cone. No, I'm sorry, the volume of a cone. And on this side is going to be capital V over pi r squared. Guess what? Done. Single step to undo the multiplication. A single step to undo the multiplication. Interestingly enough, my number 6 is our surface area. Little bit different. Actually, I'm going to leave this with you guys because it's very similar to the one that I just did as the example. And this one wants you to solve for little s again. I think it is, isn't it? I think it is. It is going to be. So if you have the work, you're good to go for 6. Let me drop 4 in here, and then you guys will have the literals done. P equals, I don't know what this one's for, 2 times V. Solve for V. Nope. Why would I use subtraction to undo a multiplication problem? What are you going to do? So what would V be? How would I express capital V? That's it. That's it. So 2.4 properties, a couple of 2.4 properties that I want to give you examples of how they're used in geometry. One of the properties, let's talk about the addition property of equality. The addition property of equality, we've used it in terms of solving equations, but I'd like you to see it in a geometric setting. So I'm just going to give you an example of how we would use this. If the measure of, I don't know, angle N is 40 degrees, then the measure of angle N plus the measure of angle J would be equal to what? And it really is all about an addition problem. What did I put in, or what did I add over here on the left side to the measure of angle N? What did I add to the measure of angle N? I added the measure of angle J. So to get from here to here, I actually literally added the measure of angle J. If I do it on the left side, I have to do it on the right side. So I would come down and say the addition property of inequality, if you want me to put together the measure of angle N and the measure of angle J, well, that's going to be equal to, I know N is 40 degrees plus whatever the measure of angle J is. So again, I wanted to show you how the addition property of equality could be used in a geometric setting. How did I get from here to here in blue? I did that by adding angle J to both sides. And so down here my answer just said, well, that was 40 degrees, add angle J to it. There's another property that comes up, and it's kind of a, I don't know, I kind of find it to be a silly one, but at the same time I see where it can be used. It's called the reflexive property of equality. And the reflexive property of equality, it's weird what it says. It basically says like, let me give you a couple examples. The reflexive property of equality says something like segment AB is segment AB. Like, that's it. It is what it is. All right, so reflexive. But I'll tell you, let me give you a better example of why this would be important. Like, it is what it is. Like, this is the property that says it is what it is. But let me show you about how this would work in another instance. If I knew that the measure of angle 1 plus the measure of angle 2, that's a plus sign, was 180, these guys are supplements. Let me say also that the measure of angle 3 plus the measure of angle 4 are also supplements. If these are both supplements, I'm going to put if, and, I'm going to follow up with a then. If they're both equal to 180 degrees, this reflexive property gets us to say, well, their sums must be equal to each other. Their sums must be equal to each other. Since they're both equal to 180, I can set them both equal to each other. That's just a weird use of this it is what it is property. Since their sums both are 180, then they're both equal to each other.